So now I'm going to be covering LeetCode problem number 508, which is marked as a medium problem, and it's titled most frequent subtree sum. So given the root of a binary tree, we need to return the most frequent subtree sum. If there is a tie, we need to return all the values with the highest frequency in any order. The subtree sum of a node is defined as the sum of all the node values found by that subtree rooted at that node, including the node itself. So for this example, if you see, for 5, the subtree sum would be 5 plus 2 plus minus 3, that is 7 minus 3, that is 4. And since it is said that we need to return all the values with highest frequency in any order, highest frequency for the same node that is mentioned. So if we had two nodes of the same value, then we'll consider the highest frequency. But right now, since we have all different nodes, so we can choose any one in any order. For 2, the subtree sum would be 2 has no left or right child, so it would be 2 itself. That's the value of the node itself. And for 3 also, minus 3 also, we have this it's no left or right subchild child, so subtree sum would be minus 3. Now similarly, for this example, 5 2 minus 5, we basically have, for 5 the subtree sum would be 5 plus 2 plus minus 5, so this would cancel out and the subtree sum would be 2. Similarly, for 2 again would be 2, and for minus 5 we won't have minus 5 because the answer would be requiring us to get the highest frequency for that. So that is why only 2 is the answer, right? So that is our question, that we need to find the most frequent subtree sum. So now let me bring you to my solution that I posted on LeetCode. So this is the post order solution, right? So intuition is that each node in a binary tree has a subtree sum, that is node's value plus sum coming from the left subtree plus the sum coming from the right subtree. So let me show you. For example, this is the binary tree. Let us say this is the binary tree, right? And we basically need the subtree sum for this node, right? So that would be basically sum is equal to this node's value, that is this node, plus the value that is coming from this subtree, L subtree, plus the value coming from the right subtree. So that is equal to the sum, and that exactly I have written here. So now the goal is to compute all subtree sums, track the frequency of each sum, and return the subtree sum that occurs the most frequently. So post order is the best for bottom-up aggregation like subtree sums. Now in this problem we will be using a map that helps us efficiently track and find the maximum frequency, and reverse the tree once, that is computed in linear time, that is O of n time, where n is the number of nodes in the tree. Our approach would be simple, that is we perform post order traversal, that is left first, then going to the right subtree, then going to the node itself to compute the subtree sums, and maintain a map that is sum to frequency to count how often each subtree sum appears. Then we keep track of the maximum frequency as we go. After traversal, we loop through the map and collect all sums that have the highest frequency. Okay, so the complexity, as I had discussed, both the time and space complexity are O of n. Since for the time we visit each node once, so that would be O of n. And for the frequency map, that is anode map we use, and recursion stack, we have O of n only. Right. So let me take you over to the code part. This is the code part. So our function is basically find frequent tree sum, and we have our root passed to this function, and we return a vector of int that would be storing basically, res is basically the vector of int that would be storing all sums that have the highest frequency. So we store basically the subtree sum and its count in the unordered map named as frequency, and maximum frequency we set a variable in order to keep track of the maximum frequency for each node that is going to be calculated, right? So then we call the function dfs of root, right? So now let us go over to the dfs that is used to basically recursively compute the subtree sums, and dfs we call here we passing root, the frequency map, and the maximum frequency that we can get from that particular node. So first we check if the root is null, then we return 0, because then sum would be 0 for that subtree, because if that particular node is null, that means it does not exist. So the sum, it would add a null value, 0 value, right? So we put this check, then we calculate the left and right sums by going to the corresponding left child and the right child of that particular node. So this left value and the right value we calculate and store it in LSum and RSum, and the current sum would be the, as I said, the node's value plus the left subtree's value, and the sum of summing it up with the right subtree value. So that we have done here again, and we map basically add that sum to the map. So this current sum and its frequency starts coming here. So let us say the frequency is here 1, right? So that gets updated in the map, frequency map. And maximum frequency, we check that whether it's the maximum frequency, whether this frequency is maximum, that is the frequency that we have initially set, that is 0, or the current sum is maximum. So that is updated here to track the highest frequency, and we return the current sum, right? And finally, all sums that have the highest frequency need to be returned. So For going over the frequency map, the first element is the sum, as I have said, and the second element is stored as frequency. So this pair basically, the pair's first element is the sum and the second element is the frequency. So if the count that is the frequency is equal to the maximum frequency, then we push this sum into our answer, right? Because we want those sums only that have the maximum frequency, and that is exactly done here. So if count is equal to maximum frequency, then we push it into our answer and we return the answer. So that's it about the video. That's how you solve most frequent subtree sum.